Okay. What I'm saying in this lecture, again, because I didn't, I start recording now. We will be continuing with the state variable. We will be solving the differential, state space equation, which is basically a differential equation of this format. And then once you have the solution for the differential equation, you can definitely substitute in the second equation to get the output. We also, most likely not in this lecture, we will utilizing the signal flow graph in representing the state space, and that will help us in relating the three different models in this course, which is differential equation model, transfer function model, and state space model. So we will try to utilize the signal flow graph in relating them together. If you remember, those are related by just taking Laplace transform over the differential equation and setting the initial condition to 0. You'll get the transfer function model, and the transfer function model you can go back by changing every s variable into a derivative. Okay. Then we would like to do in this lecture, we'll show you how to go in this way. And later on, maybe, as I said, next lecture or 2 more lectures, we will be, dealing with everything, all the model together. Okay. So now let me have more example. In here, I have, a rocket. I am, launching a rocket. I'm assuming this is my reference. This is 0, and this is the x direction. Okay. And I would like to, get the state space model for this system. So I need x dot equal ax plus bu. Okay. Now, let me start usually the same thing which we have done in the transfer function. If I want to do the modeling in here, I will start from the differential equation model, or basically I will start by putting the free body diagram of the system. So what are the forces acting on this system?
You have the weight of the rocket.
The weight of the rocket, which is mg, and the force of thrust.
Thrust.
Okay.
ايش اللي دكتور force of thrust?
What
is the thrust force?
What is the thrust force? It is, look.
يعني دفعة الانطلاق يعني ولا
look, wait. When you drive your car, you push on the gasoline. The gasoline will burn. This is your, the force will come from burning the fuel. So the thrust, basically, it is the force of the, when you are launching the rocket, you are igniting the system, and you need to calculate how much force you need to start launching that rocket. So it's the force which will take the rocket, lift the rocket up. Okay. So it depends on the size of the rocket. Of course, you are going to, engineers will be seeing how much force they need. Okay. And they translate the force through, burning fuel.
I imagine, Doctor, with this example, what they are doing in SpaceX. I'm sure you're familiar with what they are doing in SpaceX.
If?
In SpaceX, in Elon Musk.
Look.
Do you hear me, Doctor? Or?
I didn't get you. You have a rocket. Suppose this is in NASA. Okay. NASA.
Yes. I'm just saying.
Launching place. Okay.
Yeah.
They launch the rocket. This is, I am sure you have seen many rockets when they launch them. Okay. So you will burn the fuel, okay, to lift, your rocket. Okay.
Yes, I get this. I'm just saying, in SpaceX, or those who are interested in that, and we are just analyzing 3 or maybe 4 parameters, but maybe they have many parameters they are analyzing.
No, what we are doing, we are just, the starting point. We are not, there are definitely many parameters. You have to adjust the direction where, you want your rocket to go, which direction after the liftoff. Then also the mass is going to be not constant, it will be variable. But, you know, we are just taking simple thing, you know, we are just, you know, lifting, you know, and we want to model that process. Yeah, definitely, you know, this is very complicated system, but we are just taking, you know, the initial step of launching. Okay.
تمام.
Then we will have definitely the friction, which is proportional to the speed. So if I have those are the you know, forces on this rocket. So let me apply. Okay, what is then apply Newton's law in here? What's Newton's law in here?
Would have m
Okay,
g f of u equal.
minus
If you want to take it this way, no problem.
x dot minus g. Sorry, mg
Equal 0.
equal to what?
Equal 0.
Newton's
We have the thrust force or the net force
Newton's law.
equal m acceleration.
second derivative of x.
The acceleration. So now I have a derivative. Let me rewrite my derivative. Let me write m x double dot plus kx, and let me put the force or the input in the other side. Okay. Okay. Oh, sorry. No. Let me solve for yeah, just x double dot. Sorry, I have, yeah, as I said, I have m x double dot plus k x dot, okay, minus or plus f u minus mg. Let me call this is together as my inputs. This must be equal to 0. Because look, the mg at the beginning, you know, the mass we are considering to be constant. So whatever the force you have, subtract a constant from it, and that will be your input. So now I'm representing what is the system order now.
It's in the second order.
Second order. I'm representing my system by a second order differential equation. What I want to do, I want to convert this one into two first order, okay, two first order differential equation. So I should have, if I want the state space, should have the dimension of the A matrix is going to be 2 by 2. Or I will have two state variable. Because remember we said, if you have nth order differential equation, you would like to convert it into n first order differential equation. So if this is the case, I'm rewriting it in this way, or after you divide by m, this is basically what you have. Now, let me assume the first state variable, x1 equal to x, which is the rocket position. So basically, the state variable has a physical meaning. In the circuit, if you remember, we consider either the voltage across the capacitor or the current through an inductor. Now in here, I am assuming my state variable, let's say the first state variable will be the position and the second will be the velocity. What I need in this model, I need, okay, x1 dot. What does this equal to?
x2 dot.
It's going to be x dot.
Or x2.
Which is equal to x2. So I have, this is one differential equation. Let me get the second differential equation, which is x2 dot, which is equal to x double dot. But this one, let me use this equation. So from this equation, I have x double dot equal minus k over m x dot okay, plus, okay, fu, okay, minus g, okay, this over m, let's say, and yes, okay. Now, if I want to substitute in here, so this is equal to minus k m, and this is x dot. What's x dot equal to? What's x dot equal to?
X2.
X2 plus, okay, plus, you can put u. I'm assuming this is equal to u. Maybe, I don't know, in the okay, yeah. So if this is the case, okay, if this is the case, this is what I have. Let me convert this one into a matrix, because remember, I want to write it as x dot equal ax plus bu. So let me put x1 dot, x2 dot equal to a matrix x1, x2 plus u. So what will be the element of the matrix from the first equation? What do I have? What will be the
0, 0, 1.
0, 1. How about the second one?
0.
Minus k over m. And then
Yes, correct. That's correct.
Okay. Now, this is the, so basically, this is your A matrix, and this is the B matrix. I need now the C matrix. C depends on the output. So let me assume I'm taking my output to be the position. Let y equal to x1. So in this case, what is the matrix will be? One, 0. And this is my C matrix. Okay? Then D matrix will be 0. There is no connection between the input and the output. However, if I want Y to be X2, what will be the C matrix?
0, 1.
0, 1. X1, X2. So depending how do you define your output. Okay? So this is basically what we are saying, how, I can, model, in this case, a mechanical system by state space representation. Again, the starting point is your differential equation. In the case of the electric circuit, you can, you can do it either way, but usually differential equation and then convert. Or from the beginning, you assign your state variable in there.
طيب يا دكتور الآن why we need y of t is equal to c multiplied by x. يعني usually we define x1 for example as x and x2 as x dot, right?
Okay.
فليش ما نقول والله يعني we just write down the relationship between the x1 and x2, the variables that we defined later on, just to convert, to transform our system into first order differential equations. The relation between these variables and the main variables, which is x, the position of the rocket. In this way, we have all equations that we need يعني to solve the system.
What do you mean? I didn't.
يعني الحين يا دكتور حنا السيستم الجديد فيه x1 and x2, right?
Correct.
And the main system we have only x.
The main system we have x.
Yes, and the new system we have x1 and x2.
Position. طيب, so
ممتاز. فخلاص احنا بما ان عندنا new system is having x1 and x2 والoriginal system has x, we need equations for the relationship between x1 and x2 and x and the relationship between x1 and x2 and
No,
the
no,
main.
what do you mean x1, x2 and x?
يعني هي الديفينيشن اللي احنا سويناها.
No,
we
in here,
define.
look. This is, look, this is a physical system. I'm defining, okay, for this physical system, the state variable to be, it has a meaning. Later on, what you are suggesting maybe, for suppose you have any general system, a differential equation, and we are going to come to it. Suppose I have, okay, a differential equation, let's say x triple dot plus 3x double dot plus 17x dot plus 16x equal to u. How do I get the state space representation?
The same, we will have x1 equal x, x2 equal x dot, x3 equal x double dot.
So basically, again, what I'm saying, we are giving a systematic way of converting these differential equations into state space. I don't know, honestly speaking, I couldn't get you what you are trying to say.
يعني دكتور الحين الايكويشن هذه انا فاهمها اللي احنا شو اسمه وصلنا لها اللي هي الاكس 1 دوت اكس 2 دوت ايكوال الاي ماتريكس ملتبلاي باي اكس بلس بي. هذه is fine. طيب why we need now to find y equal cx? يعني what is the idea of finding y equal cx? Why we need it?
What's the idea of y equal to, because I want to put y in terms of the state variable. I want, you know, my system is A, B, C, D. I want to keep the states, the input and the output only. So I need it, that's why I need it. I need to define my C matrix. And that will give me the relation.
Maybe with examples it will be clear يعني أكثر.
Okay, now, as I said, this is, you know, we will come later on, we will, you know, discuss the, in general, if you have, you know, a differential equation or a transfer function, how can you get the state space representation? But now, let me move into the solution of the differential equation. I have, remember, I have x dot equal ax plus bu, y equal to cx plus du. The problem is in solving the differential equation, because the other one is an algebraic equation. You just, you know, if you have x, if you solve x, just substitute in the second equation and you will be done. Usually, you are given the u and given the initial condition, okay, find the solution. I'm sure in the differential equation course, Math 202, you have done many way of solving the differential equation. What we do in here, what we are going to use in here, we are going to utilize the Laplace transform. Okay, I will be solving the differential equation by going first of all to the transform domain, do the manipulation, and come back to the time domain. So if I want to solve this differential equation, let me take Laplace transform. What's Laplace transform in here going to be?
S x of s.
X of s minus.
We assume the initial condition to be 0, right?
No.
No. So
we are not taking transfer function.
I see.
Not
so
taking,
x of
we
0.
are solving a system. So this is x of 0 equal to ax s. Zuhair.
Yes, I opened it by mistake.
Please. Ax plus b, of course, of s, u of s. Now I can solve for x, so I will have, okay, s minus a x of s equal to x of 0 plus bu, or x of s equal to x of 0 over s minus a plus B over S minus A, okay, U of S. Now, if I want to go to the time domain, what is X of T?
X0 multiplied by e to the power 80.
So e to the power 80 X of 0 plus, what about the other term?
We need to know US.
If
We need to know US.
exactly, you are absolutely correct. We need to know what is U of S. But if we don't know it, okay, basically we take the, you know, in the time domain, I will take the
Convolution.
which is basically the from T to, from 0 to T, e to power I think e to power A.
80.
Okay, AT minus tau, U of tau, d tau. So basically, times definitely times B, the B in here. So basically, what we will do, we will take the convolution. Okay. If I know, for example, if U equal to a step function, well, definitely I substitute in here U equal to 1. And then evaluate, or from the, you know, from the last step, basically, if U equal to, if the input U of T equal to 1, step function, then this is going to be 1 over S, and I can, you know, do the, you know, partial
fraction.
Okay. But in general, if I leave it in term of U is non-function, but it is variable, it's changing. So I will use the, you know, the convolution integral. This is the relationship between them. Now, let me extend this method into the, okay, the matrix. So the solution for the first equation, for the differential equation, is going to be, okay, is going to be X of T equal e to the AT X of 0 plus from 0 to T of e to the A T minus tau B U of tau d tau. It's exactly the same. However, now we are, you know, using matrices. Okay. The problem is, suppose suppose A equal to minus 1, okay, minus 3, 0, and minus 2. What is E? Find e to the A T. What does T equal to? That's basically e to the minus 1, 0, minus 3, minus 2, T. What does this equal to?
We'll do it term by term.
K?
Sometimes they do it term by term. And you do it element-wise operation.
So basically, what are you saying? Is it equal to e to power minus T, e to power minus 3T, 0, and sorry, e to power 2T? Is that what you mean?
This is incorrect. This is not what we are interested in. But this is what MATLAB would do, yani.
We would like to do, but this is, as you said, this is not correct. Unless, okay, if this is, let's say, suppose I have, let me clear, suppose A equal to minus 1, 0, 0, minus 2. Now e to power, e to the AT equal to, in this case, it's special case, e to power minus T, 0, 0, e to power minus 2T. This is if the matrix is diagonal, then e to the AT is going to be, you know, you will take the element across the diagonal.
This is proven from the eigenvalue decomposition, صحيح?
This is the idea, and they, you know, generalize it to the eigenvalues. But the idea comes from the diagonal matrix. If you have diagonal matrix, this is what you are going to have. So what they thought, if I have a general matrix, I can diagonalize the matrix and do the process. This is one way of doing it. What we are going to do, however, in here, one way of finding e to the 80 is we will be using the Taylor series expansion. Okay? We will be using, remember Taylor series?
جميل.
You have taken Taylor series what? Math 101, Math 102, Math 201, I don't remember.
102.
102.
Okay, and 102. So look, suppose I have A equal to 0, 1, 0, 0. Find e to the 80. Find. So according to Taylor series, what do we have? E to the 80 equal to what? The first term will be what? If k equal to 0, this will be 0, so this is 1. A to the k, A to the 0 is identity.
1 كل 1.
So it's going to be identity.
Yeah.
I'm talking about matrices now. Plus, okay, T, A plus, okay, T square over 2 factorial, A square, and so on. A cubed, and so on. Let's say T cubed, 3 factorial, A cubed, okay, and plus on, so on. So let me evaluate first of all, what's A square? What's A square? A square will be what? A times A.
Multiplication of the two matrices here.
And what does this equal to? What's the multiplication will be?
Zeros. كلها zeros.
Okay. So if it's A square 0, what will be A cube?
خلاص ممتاز كذا ريحنا.
So it will vanish. So e to the 80 in this case, e to the 80 for this particular matrix, this is equal to 1, 0, 0, 1 plus T times A. So it's going to be 0, T, 0, 0, which is equal to 1, 0, T, and 1. And this is e to the 80 for this particular matrix.
ودكتور نفس الكلام هذا لو استخدمنا تايلر سيريز we can prove انه الدياجونال will be e to the power 80 will be في الدياجونال يعني will be لانه a squared it will be equal a to the power 3 it will be equal a.
كيف؟
في الدياجونال ماتريكس e to the power n equal a.
That's correct.
فنقدر ناخذها كمان فاكتور.
لا هي بالdiagonal look, if you have a diagonal matrix you don't need this one. Well, I told you go directly. There is no need to use.
لا قصدي to prove يعني to prove انه e to the power.
لا بس انه you don't need it يعني. Okay. Now, but the problem is with this one, this is not good. It is, even though in theory it's fantastic, but the problem is if suppose A is, let's say -1, as I said, -2, 0, and -3. In here, if you use the Taylor series expansion, there is no guarantee that you will be, having a closed form solution. Unless, it's special cases when you have, sine or cosine, you will have alternating, and you can figure out what does this series look like. But generally speaking, we don't use this method unless A is an matrix. An nilpotent matrix as a matrix, A to the n equal to 0. Okay? So, what do we use?
Sorry, Doctor.
Shabab, okay, let me stop in here. Let me stop in here. So I will give you time to to switch to the Blackboard. Okay. Please try to enter on time.